In this video, we're going to talk about how to find the area of a triangle in the side angle side situation. In other words, we know the lengths of two sides, the measure of their included angle. Side, angle, side. Okay, we remember that from when we were proving that triangles were congruent. We had that side, angle, side as one of our congruent shortcuts. This is an alternative to using our formula for area equals 1/2 base times height. And as you saw in your notes, or hopefully have seen in your notes, we developed a formula that involves the sine ratio as another way of finding the area. In order to do it, though, we need to know two sides and the measure of the included angle. So in this particular case, I have these two sides, this included angle, so my area is going to be 1/2 the product of the two side lengths, so in this case 29 centimeters times 25 centimeters times the sine of 65 degrees. Now, how's that going to work out? How's this the same? Well, as we saw when we developed the formula itself, if I consider 25 centimeters to be my base, then my height would be the length of the altitude coming from point A. But the sine of 65 degrees in that right triangle would be the altitude length, and that would act as a hypotenuse. So if I solve for that length, I'd have the hypotenuse times the sine of 65 degrees. So that's where those two measures are the same as the height when I multiply those. Or if I thought about this side as being the base, then the altitude to that side, I'd have a right triangle. Sine of 65 degrees would equal the altitude divided by 25 centimeters. This would take the place of the height. So it doesn't matter which way I look at it there. So now I've solved for my variable. The variable is area. I'm ready to take out my calculator. My area, it's probably not going to be coming out to a nice number there, so I'm going to write as approximately equal to. If I zoom in again, 1/2. I know that's 5/10, but I'm going to do it as a fraction, so I'm going to use the parentheses. 1/2, close the parentheses, whoops, accidentally hit 1/3, parentheses, 1/2 times 29 times 25 times, remember for the sine I have to do the 65-degree angle first, then hit sine. Now that number is only the sine of 65 degrees, I have to hit equals. Okay, my area is about 328 5/10. Now, what would be the label? Well, I have centimeters times centimeters, so my label is going to be square centimeters. Pretty straightforward. Now, let's look at a problem that's a little bit trickier. I don't have a triangle. This is quadrilateral. Well, maybe I could use that formula, however, if I were to divide this quadrilateral into a pair of triangles. Now, I'd want to be a little bit strategic about where I put my division, but because I know the measures of these two opposite angles, I think I'm going to put in the diagonal from D to F so that Here I have two sides in the included angle in that triangle, triangle DEF. I have two sides in the included angle in that triangle, triangle DFG. And so my area would actually be the sum of the areas for those two triangles. So I'm using the same formula, but using it for each triangle. So I'm going to have 1/2 times, let's do this triangle first, 124 centimeters times 115 centimeters times the sine of the included angle of 78 degrees plus, because we want to add to this area, the area of this triangle, here we're going to have 1/2 times 95 centimeters times 104 centimeters times the sine of 100 degrees. I've solved for my variable. My variable is the area. So I'm ready to use my calculator. I'm going to do that whole thing. There's no sense, folks, of doing the individual multiplications and so on. If I have it solved for my variable and I know I'm going to get an approximate answer, this is where I want to do my calculation. Plus, that way I'm only rounding that final answer. Okay, these individual answers aren't going to be nice numbers. If I round them and then do a calculation and round again, that can lead to error. So, 1/2 times 124 times 115 times, for this calculator, 78 sine. Now, plus, parentheses 1 divided by 2 times 95 times 104 times, have to do the 100 degrees first, so 100, then the sine, now hit equals. So our area is pretty big here. It's about 11,839 and 1/10. 11,839 and 1/10. And centimeters times centimeters, I'd have square centimeters for this part, square centimeters for this part. So when I add square centimeters to square centimeters, I still have square centimeters. Now, that's one that, boy, is that even a reasonable answer? Well, if I just made an estimation here, 100 degrees is a little bit bigger than 90. This is about 100. 100 times 95 would be 9,500. You know, this triangle is a little bit smaller than this one, but 9,500 for a rectangle that's 95 by 100 is pretty reasonable that this would be the correct answer, since this is a little bit bigger on this end. Okay, those are the two examples for areas using the sine.